Hello, Munchmo here. Welcome to my introduction to visual scripting in Unity. Visual scripting was originally offered as an add-on called Bolt, which has now been integrated officially into the editor as a native feature starting with version 2021.1. Visual scripting is a powerful way to program in Unity that allows you to do anything you want without the need to actually write any code. Instead of writing scripts, you combine visual scripting nodes inside of graphs. These graphs can be attached to any game object, whether a prefab in your asset library or an active object in your scene. Alternatively, you can build nested subgraphs, previously known as superunits, to simplify complicated processes within other graphs. I want to stop for a moment and ask for your help. Because this is my first foray into teaching Unity visual scripting, I want you to leave a comment below the video with topics you'd like me to cover in future videos. I already have a lot of tutorials planned, but I prefer to give you exactly what you want. And of course, while you're down there leaving that comment, I'd really appreciate it if you click that like button and subscribe to my channel. That way you won't miss out on anything. To begin visual scripting in Unity, you must first have a version of the editor installed that supports it. Head on over to the Unity download page and install the Unity Hub. Once it's installed and running, you just need to choose your version. Unfortunately, at the time I'm recording this video, there isn't a long-term support version of Unity that includes visual scripting. As long as you choose a version greater than 2021.1, you should be good. If at the time of watching this video and you're getting ready to get started, there is an LTS version that supports it, you want to install that version. No matter which version you choose, I do recommend that you stick with that version through the entire life of your project. Now that the Unity editor is installed, let's have a look around. As you can see, by default, it has the visual scripting package installed. However, the version I have does have an update available to 1.76. You can choose to update it. When you begin, I again recommend that you start with the most recent version of visual scripting installed. But once you have that installed, do not update throughout the life of your game. Unity also has its own preferences here that you can set. I have a couple of recommendations here specifically within this is the option to predict connection values. By default, I believe that one is turned off, but that is very handy for state graphs, state reveals, and transition reveal. I like to be able to see what those are. And then down in the actual project itself too, you have more visual scripting things here. If you ever need to add anything new to your project, you would do it in here. Just like if you ever need to add any extra nodes, you do it in here. One I recommend, if you're going to be using Text Mesh Pro, you do want to add that here. You just click the little plus button, pull it down, do your search for whatever you're trying to add, and then you need to regenerate your nodes. Same thing goes down in here. Once you've added it, you can add your Text Mesh Pro right here as a unit. Now it's time to dig into the innards of visual scripting. You can add the visual scripting component to just about any object in your scene, as you would normally. You've got machines, a script machine and a state machine. The script machine is probably what you'll use most often. The machine has two different sources. You can have a graph, which is something that you'll have created somewhere else in the project that you can attach to it, or you can have an embed, which allows you to have the graph attached to this and not be reusable among other objects. Embedded graphs can be converted, and just as such, you can have an actual graph attached and convert it to an embedded graph here, like this, and then go into the graph itself to make your changes and settings and such. The state machine is almost exactly the same as the script machine in regards to the interface on the object, but the actual state machine looks completely different. We will be going over each of these types of graphs separately further on in the video. Now it is time to dig into the visual scripting graph interface. I'm going to go ahead and use an embedded graph just to simplify life a little bit here. All you have to do is click the edit graph button here, and voila! The default starting graph for a game object that's in the scene shows up. You have the onStart event and the onUpdate event available to you in the graph. You can title the graph anything you want, give a summary of the graph. There are other options here, trigger inputs, trigger outputs, data inputs, and data outputs, that are more useful on subgraphs than on actual graphs here. And then down here in the blackboard, we have access to all the different variables available within visual scripting. You have graph variables. They are local to the current graph, and only accessible from within this one graph itself. You have an object variable that gets attached to the object, can be accessed from any graph within the scene. You have a scene variable that is accessible by anything in the scene and will hold it throughout the scene. You have an app variable that is shared across scenes, but they are reset once the application quits. And then you have saved variables that persist even after the application quits. Unity object references are not supported, so keep that in mind. You cannot have a saved variable save an object. It can only save simple variables such as strings and integers or floats, vectors, that sort of thing. When it comes to save variables, you also have two different states for each variable. You have the initial state of the variable. So test saved variable. We can make it a string, give it a value of testing. And then you'll see we have this. It doesn't exist here because this hasn't been changed at all while playing. A few more notes about the visual scripting graph interface here is you can actually disable your graph inspector and your blackboard with these buttons over here. You can always make this section, well, bigger, not really smaller. You can move it with this button here to the other side. You can have it on both pieces, one side each, however you prefer. It's up to you. You can actually zoom out to be able to get a potentially better view of your graph. The other thing here is if you move, you scroll around the graph like you do in Unity with the middle mouse button click, hit the overview button, it centers you back on the whole thing here. And if, unlike me, you like to use the script graph interface inside of the actual full Unity window, you can hit this full screen button and it'll give you a bigger view of it. But I personally prefer to have this actually blown up and actually a full screen window myself because it gives me a lot more room to work with it. And if you really are getting confused on things and you want to have an even better view, you can turn those guys off over here and have more room to work with. Now it is time to dig into visual scripting with graphs. As you can see, I've added a canvas and a button here just for example purposes. We will go in here and add the script machine component. Now, for simplicity's sake, I will be using embedded graphs here in this tutorial, but feel free to do it whichever way you feel most comfortable with. When creating a new graph on an object, you will automatically start with these two events, the onStart and onUpdate event. But because we are working with a button, we will not be using either of those two. Instead, the event we will use will be on button click right there. And now this on button click is the same thing as if you were putting him in this list over here, but instead it is in visual scripting form. So what we're going to do is we're going to do something that a lot of video games have. We're going to instantiate an object. You just right click on the empty graph and you just type what you're looking for. And you just got to figure out exactly which one you want. Now we're going to be setting position and rotation here. And now we need to tell what we're going to instantiate, which object it is. We can either choose to do this, and it'll ask us to, what exactly we want to do by context of which one of these data lines we pull off of. Just like over here for position, it'll give us the option for vectors, and rotation, it'll give us the options for quaternions. We also have the option to click on this little circle here and then search our scene or our assets for what it is we want to put in here. And the last option we have is we can actually click and drag this into the scene here, or we can click and drag this directly into that spot right there, which is exactly what I want. We are going to go ahead and set the position with a vector 3. Now, you'll see here that our flow line here goes to this game object, but it doesn't connect to this vector 3. You don't have to connect through the flow lines if you don't want to. all the time, but that will determine the execution order in which this vector3 is created. So with the way it is now, it pulls into this and it's executed as it's calling this instantiate, where if we wanted for some reason to actually execute it before the instantiate, we can do that like this. It is, in this circumstance, it is actually not very important. Now with the instantiate that we've chosen, we do have to have a rotation here. If we did not have that, it would fail. So now we have created this graph that when we click the button, it will take this explosion and spawn it in the middle of our game world here. So let's hit play and I will show you what this does. Bam! How's that? Pretty cool, huh? And of course, any subsequent click will create another one, but we can't tell it's there because it's just overlapping with the existing one. So what I'd like to do now is we're going to modify the explosion itself by adding a script machine. And again, I'm using embedded graphs. Since this is a prefab we're using, we have to edit the graph on the prefab itself. If we were to actually drag this into our scene here and try to edit the graph, you'll see changes made to embedded graphs on prefabs will not be synced. So we can't actually make any changes here. It won't even let us. You see, we can't click on anything. And then down here, component graph editing is disabled on prefab instances. So we actually have to edit the prefab graph itself. Anyway, we're going to go in here, we're going to edit this graph, and we are going to use the onStart event, but not the onUpdate event on this one. So I will remove that. And so what we're going to do is we are going to first, when this thing is created, we will set the local scale on this object. Obviously, when we start it, we could technically have it choose from any object at all. Now you'll notice this one I only have access to assets. I don't have access to scenes because I'm editing on the actual prefab, which does not exist in the scene yet, so it does not know how to access scene objects. So if we needed to grab something from the scene, we would have to instead GameObject find name, just like you would anything else. You could find a GameObject by the name. We could actually choose the GameObject here. But what we're going to do is we're going to be operating on this anyway. And then on the object itself, we will add a variable here called min_scale. And mind you, this will be a float type. And we will just go ahead and set it 0.5. And we will create a variable called maximum scale. And in this maximum scale, we will also set this to a float of 1.5. And then we can actually click and drag these out here, just like that, to get the variable, right? And then we can also, if we wanted to change it from in here, we would Alt-click, and that gives us the option to set the variable, but we're not going to be doing that right now. And so what we're going to do is we are actually going to create a vector3, and we will then feed a random generator in here, like this, and this random generator, minimum scale, maximum scale, feed it in there. This one will be 1 by default. Take this, duplicate it, and then feed that into there. And so what this will do is when we push the button, it will randomly change the scale. Bam, 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 bam. As you see. Very good. Now, once this happens, we are going to want to make this destroy itself. We don't want it to happen right away, so we're going to trigger a custom event called destroy. It's going to try to run a custom event trigger here on this object, but it doesn't exist. We actually have to create that custom event here called destroy. Now, we don't want it to happen right away. We want to be able to put a wait in there. So we have to set coroutine up here, which means that it can operate independently of other things here. So then we put in a wait 4 seconds, and we're going to just let it have 3 seconds. From here, we will destroy GameObject. And we will set this to this. So which game object are we destroying? We're destroying this game object. So now, when we go in here, we go boop, and then 3 seconds later, it disappears. And then we can do this a million times if we want to, and eventually they'll start disappearing over time. As you can see, they're going away. Some things of note when it comes to visual scripting graphs, the data that you enter is extremely sensitive. Take in mind the name of the variables. They are case sensitive. So if this has a capital M and a capital S over here for my min scale, if I am going to add a get object variable, I would type in here min scale like that, where if this is lowercase s, that would be an entirely different variable. Mind you, you can also use the pull down to select the appropriate variable name. Another thing to keep in mind is the more you can reuse a single node, the better. So doing something like this is a completely valid option. However, if we were to eventually try and change the value of this over here, and then use the variable over here, you'll see the value still says 0.5. You have to then get it from somewhere separately to get the new updated value. And lastly, when it comes to your script graphs, they can be as pretty or as ugly as you want them to be. Now keep in mind, you hold down Control, you click and drag, and it gives you the ability to create a group that you can then name, and then you can color, just so that you know what they do. You can even put a comment in here. Destroys calling object. Simple as that. So you know what it does. But this graph will work no matter how ugly or out of whack we make this stuff, and the lines, we can make them go anywhere we want and it'll still do the exact same thing, but it'll be a lot harder to understand exactly what it does if you were to do this. But as you can see, we will save it like this. We will hit the play button, and then when we hit it, it still works exactly the way we made it work. Now that we have covered the basics of the script graph, we are going to jump into the state machine. The state machine operates similar to your standard graph. However, it has these special nodes for the states. Each state comprised of specific events that are available to you. The onEnter state triggers every time the state starts. The onUpdate event triggers every frame while the object is in that state, and then the onExit state triggers every time it leaves the state it's in. As you can see, we can add script states, which are the same thing as start. We can add a super state, which is a bit different, and it contains even more states within inside of it, embedded deeper and deeper into the super states. And then you can transition from one state to another. Inside of these transitions, you can say what triggers the transition, like a custom event called back to start or something like that, and then that will jump from one state to the next depending on what's going on. And finally, we have embedded graphs, previously known as superunits, which is my preferred term for them, but these are little snippets of code, or again, groups of nodes that you have combined together that are reusable, that you can just drop inside of other graphs to make things happen. They are a bit special because they need something more than just the nodes. As you can see, I've got an input node here and I've got an output node here. That allows me to trigger them. You don't have to have both. You could have just an input node and have this do something and then it doesn't go anywhere from there, or you can have an output node and have something like a trigger. that causes this to pull out and happen inside of it. But a small example here of how this would work is if we were to go into here, we could take this and then we go and singleton. This is the one that we just created, and you see it goes into there, and then it just has an output, an exit, and then it goes through this entire process in the graph. I want to take this opportunity to thank you for watching this video. Please, again, if you enjoyed this video, if you learned anything from it, please click that like button. If you have any questions or comments, leave them below the video. And I do intend to dive deeper into a lot of the topics that I covered in this. This was just simply an introduction to visual scripting. So if there is something that you want to know now, let me know and I will see what I can do about teaching that to you right away. See you guys again next time. Have a great day.